Okay, we're doing something that's considered near impossible. We're charging up a dry cell battery. It's a 9-volt alkaline, and we're using a voltage that's lower than the battery we're charging. It's charging up to 8.12 volts. We're only powering it at 5.3. You see it goes up real slow. The more voltage input you put, the faster you're going to get this thing to charge. Anyhow, we have a variable pot on this circuit. This is a schoolgirl circuit, and we're running it's about 811 turns, and this is twisted number 30 and a number 26 wire. They're twisted together. You need to twist those wires together, not just put a bifiller. The performance suffers, as well as it's a tank circuit. The coil, two coils wrapped together, act as a LC tank circuit. So you want to put aluminum brackets here, otherwise the magnets will have a tendency to stick around this point. Aluminum here. This is 1.5 inch by 1.5 inch, and it's a 5/16 bearings inside the skateboard wheel. It's got 4 magnets on here, countersunk magnets, and we're going to have a link to the Bedini schoolgirl. It's the beginner's drawing. What we're actually doing here, we're running the first schoolgirl didn't charge batteries. It had one 9-volt battery that was supposedly running it for 5 days straight, and I can only get this to run for about 5-6 hours. So I don't know what he did to make his circuit run for 5 days, but nevertheless we charge batteries with the diode on here, which is some of his next step up chargers. The schoolgirl that won the science fair didn't have a means of charge. So anyhow, we're going to put a link to the schematics to make this thing. And he was running 450 to, I believe it's 800 turns. So you can experiment with different amount of turns, and then the resistor that controls the base current, you have to change those resistors out different values. We also put a pot on there so you can do a fine tuning. Without a pot, it's impossible to fine tune that thing. So anyhow, we were at 812, we're at 813 now. So there you have it.